Okay, let's start talking about triple integrals and cylindrical coordinates here. Here I've got a polar rectangle that's been extruded in the z direction. Okay, so you can see the changes in the coordinates are what? Delta r, delta theta, and delta z, like you would expect. Okay, my question would be, what is the area of this polar wedge or cylindrical wedge here? Okay, let's see. Well, it would be what? The area of the polar rectangle multiplied by delta z, right? Okay, now do you remember the area of a polar rectangle? It's what? R delta theta. Well, what? Where delta theta is the change in theta, delta r is the change in r, and r is actually measured from the origin to the midpoint of the polar rectangle. Here I've written then that delta v equals r, delta theta, delta z. Okay? All right. Here I've got a slide by OpenStax here. They call this a cylindrical box. That's what I was calling a polar wedge or a cylindrical wedge, whatever you want to call it. Okay? And suppose that you've got a function of x, y, and z, or r, theta, and z, if you wish, that's continuous over this cylindrical box here. Okay? And I wanted to integrate that thing in terms of cylindrical coordinates. What are we going to imagine doing? We're going to imagine taking this cylindrical box and partitioning it up into smaller cylindrical boxes, right? Taking a sample point in each of those cylindrical boxes, or sub-boxes if you wish, and evaluating that integrand, that function you were interested in integrating, at each of those points, right? And then you would multiply that result by the volume of each of those sub-boxes and add them all up. Okay? Notice here, because it's a triple integral, they're using what? They're using three indices, I, j, and k. Alrighty? So let's say I is the integral that you would be interested in. We'd take the limit as the norm of the partition. You know what that is. That's the length of the largest subinterval here. And to be summing over all the I, j, k's, here it is, the function evaluated at each of those sample points times what? The delta v here, okay? This is delta v here. Now in my previous picture here, the reason why I didn't use subscripts on the delta r, delta theta, delta z is this looks like they broke it up as an equipartition here. So in a general case here, these might have subscripts also. I hope that makes sense, okay? Now if I take the limit as the norm of the partition goes to 0, my I then would be what? The triple integral over the solid of f evaluated at r, theta, z, dv, where dv would be what? R, dz, dr, d theta. I actually changed the order from what I had in the original, because usually what we're going to have happen is what? Z is going to be a function of r and theta. R in turn will be a function of theta when projected into the xy plane, or the r theta plane if you want to call it that. Okay? And other cases here, by the way, if your integrand is naturally in terms of x, y, and z, and you're actually going to be changing into cylindrical coordinates from Cartesian, then your integrand would look like this, right? Don't forget to do this, is all I'm saying. It would be f of, instead of x, r cosine theta, r sine theta, and then you would leave z alone, right? Okay, so that's the idea. So we will be working out some integrals like this, and let's take some concrete examples now.